Okay, so now start the project demo. So firstly, this program here is running the monitoring system, and this program here is running the charge and discharge system. So this TV here is actually showing the NI web server as mentioned by Winston just now. So maybe I'll just start on by introducing you to what this is first. So this is the really board that I said just now. We actually laser design it and then we laser cut. So this is the board that is measuring the batteries, and this cover here is actually 3D printed. So this orange wire here is connecting the box to the relays before connecting to the batteries. And this is the battery box. So this load here is the load that NCA program is in that view. And this is the power supply. And this is the 4G router. And the GSM modem is right here. So this is the MyRadio, and right here is the thermistor circuit that is measuring the cell temperature. And this is the circuit that is powering up the relays. And we have drawn power from the external power supply. So in the event of emergency, you can just press the e-stop. And this is the converter box. So this is the battery box. Maybe you can. So if you open up, you can see that all the batteries are connected inside. We have two stacks, so the bottom stack is 12 cells and the top is 12 cells. So this is what's the active balancing board. Yeah, so I'll now pass on my time to NCA to show the discharging program.
So this is a 4-channel discharging. So that one the channel itself, there are 4 channels also. So you can monitor 4 channels in that. But currently you are using only channel 3 itself, carry out discharge test. So after you just set up everything here from discharge current, also the ring card discharging current, like trigger current 1 ampere example I said. And the load is start on after in the channel side, after you start conduct the discharge test also. You can see here you are remoting, so you can, from here you can see the battery side is reading voltage, right? Because they are raising energy out from the battery. And you can see the curve from here is also start discharging right now. So from curve also, then you can also sense the temperature itself. The ambient temperature, our current temperature is about 25 degrees, so it matches our environment temperature. So in any case, I power fade over power over current over voltage, right? In order to prevent system. Also internally there will be a protection is trigger, but now it's in a smooth condition. But if furthermore you want more protection, you can just press the stop button itself. And you'll see everything will stop. All the load itself will be off, all the voltage will be reduced. And this will help to protect battery. And now how we manage to open the top one on charge. So what you want
So this is where I set the charging configuration. So firstly, I can set the over voltage value and overcurrent value. So I can also set the charging current and charging voltage. So because we are using 12 cells and the full charge for one cell is 4.2 volts. So there will be 12 times 4.2 volts. This is 54.4 volts that I set here. And the current I set will be 0.2 C and 0.6 amps. So for the discharge cell voltage is where I set the over discharge voltage, then it will go to the pre-charge mode. And the cutoff current is 4% of the initial charging current, which is 0.6 amps. So I just need to press this and press this. And if I run it, it will start the charging process. And this can be monitored using a windshield system. You'll see that the voltage has to rise. And right now the power supply, the voltage is increasing. So this means that it's charging over battery pack right now. I'll now pass on my time to windshield to share more about its monitoring system.
So I'll now talk about the monitoring systems for voltage and surface temperature of the batteries. So this is the main level dashboard that you guys saw during the presentation. So here we have the port 1 and port 2. So this represents DC2259A port 1 and port 2 because we change two ports. So here we have the voltage indicator and the temperature indicator, and we also have the indicator to indicate whether if the readings are normal. And it's the same on the NI web server dashboard as well. On the threshold setting, we've set the over voltage to 4.2 volt, under voltage to 2.5 volt, and over temperature to 40 degrees. So if any of these readings are exceeded from the batteries, so it will actually trigger the system warning. So I'll now demonstrate the system warning using this hair dryer right here. So as you can see, we've set the over temperature threshold setting to 40 degrees. So if any of the readings from the thermistors exceeded 40 degrees, the system warning will be tripped. And the SMS message will also be sent by to me by this modem device right here. So I'll put my phone I'll put my phone with NJ, and I'll blow at the thermistor side. So as you can see, let me blow some.
You see there's a message coming, warning message.
Okay, so as you can see right here, it has exceeded the over temperature threshold value, and the system warning will be triggered. So now the relays connected in between the DC2259 board and the batteries are actually open. So to ensure the box is safety, and also a very annoying buzzer will be turned on to inform the users about a fault that's happened. So as you can see, and there's also a system warning SMS message sent by the modem. And so as you can see right now, all the readings are back to normal again. So now the users can just reset and turn off the warning. Thank you.
And once this system activates, all the program was stored. Everything was stored itself. Yeah.
You all have been doing a lot of things in like individual. But what's the whole purpose of this project, self-monitoring? But what's the conclusion after doing all this? What are you supposed to do?
Testing the battery. For us, it's like repurposing the battery. So usually battery is formed in many cells, right? With different cells and different characteristics. Also maybe similar characteristics. But for us to do repurposing of battery, right? We know maybe like old battery, we need to test our individual cell to see whether is it in good condition or similar characteristics. So this during the cell discharging, we can find the example. We can find the discharging curve by similar characteristics. And once the characteristics are matched together, we can recombine all the cells, workable cells together and make a second-hand battery for as a storage system for solar. So for monitoring itself, what we need to monitor individual cells. Say we need to monitor battery are form many cells together. And individual cells we can match the same characteristic also. Then this will help. If as a different characteristics match together, maybe like when use the battery, some of the cells may over discharge, or some of them maybe when do charging, some of the cells may overcharge, right? And this one will affect the whole performance of the second-hand battery. Therefore, we need to collect all the data using our system, so that when you do recombine the battery itself, right? This will help to see whether the battery is good, usable or not. Is it matched with the client's requirement also?
When you recombine, is it in cell level or in pack level?
In pack level.
In pack level, yeah. But your monitoring is in cell level.
Per cell.
We measure them per cell as the one pack of batteries can be made out of many cells. So
yeah, so that's why I say when you after you select those good ones, you pack them together. Do you monitor them as a pack or as individual cells?
Of course, we monitor them as individual cells. Then, when we found that certain cells are not up to standard. Yes, not up to standard. Yeah. Then those cells really cannot be.
Monitoring is not for you to check whether it's good. Just now the state of charge, all these are for you to pick out all the not good one, right?
That's why we need to do data analysis as shown during the presentation.
So monitoring is not the one that tell you which battery is good. This is telling the battery condition only, right? It's not for you to check which battery is good. Which battery is good is done by the state of charge and the discharge and charging, right? Then once you pick up all those individual one, you pack them together, right? Yeah. So how you monitor them? Is it individual cell or as a
pack, maybe charging.
As a pack, then this monitoring will work already because it's individual cell monitoring. So it's in the pack. Normally when you pack them together already, how you test your battery? Like I want a 24-volt battery. Yes. Individual trees, you put them series parallel together as a whole pack already, right? Then you will monitor the whole pack health, right? Not individuals.
Yeah, whole pack basically we can use our charging and discharging system. We get the good.
So that's why I want to know the purpose of the monitoring system.
So purpose to monitor the specific cell itself. Because maybe it cause unbalance or maybe over discharge the cell. Maybe this cell will be not reach the standard, or you can simply remove this cell and replace a new cell inside. Or maybe like industry, maybe some of the client want to use a old battery again, but they just like change some of the cell in the battery. They can just use this monitoring itself to monitor all the cells inside the battery. And for example, maybe this battery is only got 2 damaged cells. You can just simply take out 2 damaged cells and replace a similar cell with similar characteristics together. After they recombine, reuse it again. These all can help them to save the cost also. Maybe they will not necessarily to throw the whole battery, you need some of the cell inside the battery. Whole back, yeah.
So now your battery is, your system can monitor 12 cells,
24 cells. Yes. Yeah, you can see from inside.
Is it plug and play like I slot in and take out?
Yes.
Because I saw your thermistor is directly mounted onto the battery. Then how are you going to plug in, pick up so easily?
Yeah, so when we need to plug in, take out, we will need to obviously.
So it's not so straightforward. Because if it's straightforward, I straight away plug in, it's supposed to do everything. Someone now is directly mounted onto the insulator also. So is there any thermal thermal difference between the metal part of the battery, and because now it's wrapped with one plastic, right? I saw.
Yeah. So the inside the thermistors, right? The thermistor itself is actually exposed to the on the surface of the batteries.
So you all scrape off the
yes. We
part.
scrape off the insulation part, so we just paste the.
Then it's not so straightforward anymore. You have to scrape off, put the thermistor, then mount onto it. How you test 100 battery in one day? Not possible.
Or actually there's another way that we thought of. So we can actually insert the thermistor underneath the batteries so that we block out, it won't affect the
But you
thermistor.
still need to scrape off?
No need, you just put below.
But the insulation, the battery, how are you going to measure accurately and yet very fast? You know how you test 100 battery? Your car battery, you know how many pieces?
Yeah,
500 over pieces.
So you limit to
Every day,
certain
scrap battery, put the mixer, then start monitoring. Where got efficient?
But this we are the first batch, so everything here is from
more
scratch,
research.
Of course, there are more improvements.
Yeah, in the later on we will improve on the new
So what's
system.
the future work for this project?
So the future work can be the next batch. I think they can actually use an actual load other than the electronic load.
Yeah.
Maybe they can use it in an application such as maybe use the batteries to power up motor or something like that. And they can also increase the capacity, increase the size of the batteries. So as right now we are using 18650 size batteries. So the next batch can buy bigger and more powerful batteries.
Maybe you can get industry standard of battery for like, maybe like big battery like lithium ion. So then also you can whether monitoring this one, the whole battery doing for the application. What teacher say we are using for EV, right? So maybe the next right can talk about how this monitoring system can monitor EV car itself when using the battery energy, using energy from the battery. Yeah.
Furthermore, for the hardware part, I think they can work on the battery box connection because there are a lot of wires, so it's not really easy to think of how to connect the batteries. So they can work on that, making it more easily to take out and put back in.
So who is doing what? The whole project.
Distribution of work.
Monitoring, discharging, and
Like what you all presented.
yes.
Okay, maybe I ask for monitoring. So that's Joven, right?
Monitoring is done by me. Yes.
So for your GUI part, you did this one and
Yes.
okay, so for communication, you talk directly to the MyRip or you go through the PC?
So you mean for this web server, right?
Yeah.
Okay, so this web server,
The data is taken.
yeah. So this desktop here will first collect the data from the MyReal over there. Then afterwards, right, and it is connected to the 4G router as well. So it basically runs this web server. So and I just need to connect my laptop to the 4G router, and my laptop will gain access to the same dashboard as well. So
Okay.
So only one MyReal, the whole system.
Yes.
Okay, then question for Joven, what's the function of the multiplexer? I mean, you have your thermistors hooked up there, right? And then how many inputs of thermistors there on the MyReal?
Actually, the multimeter is Mersu's part,
Oh,
but
actually.
I can explain also.
Yeah.
Actually, the Mario doesn't have
Oh,
enough.
okay.
The Mario doesn't have enough NOR inputs, so we have to use Mario to increase the number of NOR inputs.
Okay, good. So use the
MyReal got how many input?
So
Output.
input, output.
No,
No, inputs. Thermistor.
Analog input, then the control, the digital output. How many pins?
40 digital output, I don't know.
40
no,
digital.
four.
Huh? Digital output, digital.
You need to use
Oh,
4 lah,
yeah.
but then you have how many in the MyReal?
The MyReal 40, 45. Yeah, around there. Yeah.
45, but the analog don't have.
Yeah, not enough NOR input. That's why I need to use multiplexer.
So for the controlling of the outputs again, you directly, so you said walkie right? For the outputs, so which is digital outputs you control, right? You use relays, isolating relays.
For the MyReal to talk to the analog multiplexer, we do not use. We just use wirings only.
Just wiring,
So as the commands for the analog multiplexer are just binary numbers 0 to 15. So we just send 0 to 15 through these 4 digital outputs.
Dr. Chu?
Yeah, I have no question.
Dr. Yin, do you have any questions for them? No? Good? Okay, good, thank you.